So today our discussion will be anomalous properties, behavior of lithium. So today in Part-3 we will discuss about anomalous properties and even diagonal relationship. So first of all, our discussion will be on anomalous properties or behavior of lithium. So anomalous means, in simple words, it means difference. So why lithium is different than the rest of the element in the same group? So this lithium shows different behavior or properties, okay, among the elements, okay, in the group. So you will notice in every group the first element, okay, will show anomalous properties or behavior, okay. So most of the time you will come across that anomalous behavior or property, okay, related to the first element in the group, okay. So mainly this anomalous property is because of the small size, okay, of the first element, okay. We know that when we move down the group the size increases, okay. So as we move down the group the size increases. That means the first element is the smallest one in size. So why this lithium shows this anomalous behavior or these differences, okay. The first reason is exceptionally small size. This is the first reason, okay. So extremely small size of atom and ion, okay. So smaller size of atom and ion is Li, okay. Li and ion will be Li plus, okay. This Li plus means it loses one electron. The second reason is high polarizing power, that is charge by ratio, radius ratio, okay, radius ratio. So high polarizing power, okay. This polarizing power means the power to distort the electron cloud, okay. It simply means that. And then it is also known as charge by radius ratio. So higher the charge, okay, higher or greater the charge, more the polarizing power, okay. And then higher charge means radius ratio will be small, okay. If we suppose this one, if this become 2 plus, that means size will decrease, okay, and then charge will be higher, right? So radius will decrease, okay, if we increase the charge. So when we increase the charge, we have to remove electron, okay. So when there is higher charge, it will easily distort electron clouds. So therefore bigger charge or higher charge will give a higher value of this charge by radius ratio. So because of these two main reasons, okay, these two main reasons, it shows difference with the rest of the elements in the group, okay, in the same group. So points of difference between lithium and other alkali metals. The first point is Li is much harder. So Li is small and it is hard, okay, and therefore it has high melting point and boiling point, okay. This means melting point and boiling point, okay. So melting point and higher and boiling points are higher than other alkali metals, okay. So since it is harder, it will be difficult to break the bond, okay. Harder means. And then the other alkali metals, they are soft, okay, they are soft metals, okay. So they will easily melt, okay, and therefore if they easily melt, they will have low melting point, and therefore even boiling point, they will have low boiling point. Li is least reactive but strongest reducing agent among all the alkali metals, okay. It is least reactive, okay, among the elements, but we can see a contrasting character, okay, or property it has strongest reducing agent. Okay, so why it acts as a strongest reducing agent is because it has highest hydrogen enthalpy. Okay, so it can easily take, okay, water molecule. Okay, so it can in solution, okay, this Li can act as a very strongest reducing agent. Okay, so in solution it can easily reduce, okay, the solvents. So on combustion in air it forms mainly monoxide and nitrate. Okay, so we have discussed about this. Okay, Li or Li2O. Okay, so if there is one oxygen it means monoxide, so it forms monoxide. Okay, and react directly with nitrogen to give nitrate. Okay, or lithium nitrate. Okay, now this one we have discussed. Okay, it has highest hydrogen enthalpy and is dilution. Okay, so this dilution means it absorbs moisture, okay, and crystallizes as hydrate. Okay, so water molecule is added, okay, and it forms a hydrate. Okay, LiCl to H2O. Now other alkali metals, chloride, they do not form these hydrates. Lithium hydrogen carbonate is not obtained in the solid form, while all other elements form solid hydrogen carbonate. Okay, so due to its small size and high polarizing power, okay, it polarizes the oxygen. Okay, like CO3. Okay, it polarizes this anion. Okay, or usually is negative charge. Okay, so it distorts this anion. Okay, that's why it distort this and cloud and this molecule break. Okay, that's why it is not obtained in solid form. Now the rest alkali elements, they are solid. Okay, hydrogen carbonate of the rest alkali elements, they are solid. Lithium, unlike other alkali metals, form ethanite, okay, on reaction with ethine, but so lithium do not form this ethanite. Okay, the rest form ethanite. Okay, this is also due to its small size and high polarizing power. Okay, so Na, okay, can combine with ethine, this ethine, okay, whether it's triple bond, so Na can break with this to give H, this one, okay, ethanite. Now the next one, lithium nitrate, when heated gives lithium oxide. Okay, this one, whereas other alkali metal nitrates decomposes to give the corresponding nitrate. Let's see the reaction. LiNO3, Li2O plus NO2 plus oxygen. NaNO3, sodium nitrate, NaNO2 plus oxygen. So this is monoxide when there is one oxygen. Okay, so lithium nitrate, okay, lithium nitrate directly gives lithium oxide. Okay, so on heating it gives this one, lithium oxide, and sodium nitrate to sodium nitrite. Okay, nitrate to nitrite. Okay, nitrate to nitrite. Okay, so the nitrite means one oxygen less. Okay, so it forms usually monoxide. Okay, most of the time. Now LiF and Li2O are comparatively less soluble in water than the corresponding compounds of other alkali metals. Okay. Next one is diagonal relationship. For diagonal relationship, let's see this figure. Okay, group 1, group 2 and group 13. Okay, so this one is the first element in the group 1, lithium. Second element, sodium. For group 2, the first element is beryllium and magnesium. The second one, group 13, first element boron, second element aluminium. Let's see the table also. So group 1, lithium, sodium, beryllium, magnesium. Okay, so the next group will be here. Okay, the next adjacent group will be group 13, boron and aluminium. Okay, so I've written here in simple way. So this diagonal relationship, okay, so this diagonal relationship simply means a diagonal relationship, okay, between two groups. Okay, so this lithium, the first element, okay, shows similar property to the second element of group 2. Okay, so this is okay, we draw a diagonal line and then just to show that they show a diagonal relationship. Okay, lithium and magnesium, they are similar in many properties. Okay, in the same way this beryllium of group 2 is similar. Okay, they exhibit similar properties with aluminium, so both show similar properties. Okay, so this first group shows similar properties to the second element of the adjacent group. Okay, in the same way this group 2, okay, the first element beryllium shows similar properties with the next adjacent group 13, aluminium. Okay, so this is known as diagonal relationship. Okay, diagonal relationship. Okay, however, please remember that beryllium and sodium, they don't show diagonal relationship. Okay, there is no similar properties, even boron and magnesium. So this is diagonal relationship. Okay, and because of this diagonal relationship, we are going to discuss some similar properties between lithium and magnesium. Okay, first group element, okay, and the second group element, okay, in which this magnesium is in the second element. So this similarity arises because of their similar size. Okay, small size. Li is 152 picometer, magnesium 160 picometer. Ionic radii, Li is 76 picometer, Mg2 plus, okay, is 72 picometer. So Mg2 plus means it lost 2 electrons. Okay, that's why it has 2 plus charge. Okay, so this Mg, okay, it readily lose 2 electrons. Okay, they can lose they usually lose or readily lose 2 electrons to become Mg2 plus. So they usually, this ion exists as Mg2 plus. Okay, this alkaline earth metal. Okay, for alkali they exist as plus charge. Okay, like Li plus, okay, K plus, okay, like that. Now let's see some main differences, similarities. The main points of similarity are both Li and Mg are harder. Okay, we have discussed previous in the previous discussion that Li is hard. Okay, so therefore they both will have high melting boiling point also, and both are lighter, okay, than the other elements in the respective group. Now this Li and Mg react slowly with water. Okay, so this is due to their small size and polarizing power. Okay, their oxide and hydroxide are much less soluble, and their hydroxide decomposes on heating. Okay, so that means their oxide and hydroxide are also less soluble. Okay, this does not mean they are not soluble. Okay, they will be soluble, but it will take time for them to dissolve or soluble in water. Let's see the reaction. Lithium hydroxide decomposes to give lithium oxide and water. Now magnesium oxide, this is lithium hydroxide. Okay, lithium hydroxide. Now magnesium hydroxide, it decomposes to give MgO plus H2O. So the hydroxide, okay, decomposes to give oxide and water molecule. The oxides of LiO2 and before going there, we forgot this one. They both give nitrite. Okay, Li give this one, lithium nitrite. Mg give magnesium nitrite. Now the oxides of LiO2 and MgO, Li2O and MgO do not combine with excess oxygen to give any superoxide. Okay, so they react with oxygen, okay, to give only monoxide. Okay, Li plus O2 to give Li2O. Okay, and Mg plus O2 to give MgO. So they only give monoxide. Okay, only in rare cases lithium give peroxide. So we have seen, okay, the other elements show peroxide and superoxide. The carbonates of lithium and magnesium decomposes easily on heating to form the oxides and CO2. Lithium carbonate decomposes to give Li2O and carbon dioxide. Mg, magnesium carbonate, decomposes to give magnesium oxide and CO2. Okay, the solid hydrogen carbonates are not formed by Li and Mg. This is also due to their small size and polarizing power. Both LiCl and MgCl are soluble in ethanol. Okay, now both LiCl and MgCl are deliquescent. Okay, they are deliquescent. Okay, they can absorb moisture and crystallize from aqueous solution as hydrate. LiCl 2H2O, MgCl 8H2O. Okay, they form this hydrate. Both of them from this hydrate. So this will be all, okay, for this video.